We have three main parts. So, at the heart of computer architecture, the central processing unit, CPU, memory, and input-output components. These three areas work together to make everything we see on our screens happen smoothly and quickly. First, let's talk about the CPU. The CPU is often called the brain of the computer, and just like your brain, it's responsible for making decisions, calculations, and carrying out instructions. The CPU is made up of smaller parts that each have specific jobs to do. Here's how it breaks down. Control unit, CU. The control unit is like a manager. It decides what needs to be done and tells other parts to get to work. It doesn't actually do the work itself, but oversees everything, making sure each part is on task. Arithmetic Logic Unit, ALU. The ALU is where the actual work happens. Imagine it as a super smart calculator that can handle any math problem or logical decision. Whenever you add numbers, compare things, or check conditions, the ALU is doing the heavy lifting. Registers. These are tiny, super fast storage areas right inside the CPU. They hold the information and data the CPU needs to access quickly. Think of them as the CPU's short-term memory. They only store things for a brief time, but are incredibly fast. Next up, let's talk about memory. In our computer factory, memory is like the storage room. It's where all the information and data are kept. But there are different types of memory in a computer, each serving a unique purpose. Here's the main breakdown. RAM, random access memory. RAM is the computer's short-term memory. When you open a program or file, it goes into RAM so the CPU can access it quickly. But RAM is temporary, which means when you turn off your computer, everything in RAM disappears. ROM, read-only memory. ROM is more like the computer's long-term memory, holding critical instructions that are needed for the computer to start up. Unlike RAM, ROM isn't erased when the computer is turned off, so it contains essential instructions that stay there permanently. Cache. Memory. Cache is like the VIP of memory spaces. It's super close to the CPU and allows the CPU to grab frequently used data very quickly. This makes your computer run faster since it doesn't need to look for this data in the main memory. Storage. Storage devices, like hard drives and SSDs, are where your data is kept long-term. This is where your photos, videos, and applications live, even after you shut down your computer. Now let's move on to input and output. Input/output devices, or I/O, are what let us interact with the computer. Input devices are things like your keyboard, mouse, microphone, and even a camera. These allow us to send information to the computer. Output devices, on the other hand, are things that allow the computer to communicate back to us. Your monitor, speakers, and printer are examples of output devices. They take information from the computer and turn it into something we can see, hear, or touch. Now let's talk about the instruction cycle. This is how the CPU actually processes each command. Imagine the CPU is following a series of steps to accomplish any task we give it. This process is called the fetch, decode, execute cycle, and it has three main steps. Fetch. First, the CPU grabs or fetches the next instruction from memory. It pulls this instruction from RAM and holds onto it in a register. Decode. Next, it decodes the instruction to figure out what exactly needs to be done. It translates it into a series of tasks the CPU can understand and process. Execute. Finally, the CPU executes the instruction. This could be anything from a simple math calculation to transferring data between memory locations. Once done, it moves to the next instruction and repeats this cycle thousands or millions of times per second. And then we have the concept of buses. A bus is like the computer's highway system. It's a communication pathway that carries data between different parts of the computer. There are three main types of buses in a computer. Data. Bus. This bus carries the actual data. When you open a file or click on something, the data bus moves that information to the right places. Address bus. The address bus carries information about where data should go. Think of it like the addresses of houses. It tells the computer where to deliver each piece of information. Control bus. The control bus carries commands and signals to keep everything coordinated. It's like traffic lights and stop signs on a highway, ensuring data moves in an organized way. Let's also touch on the concept of clock speed. The CPU has a built-in clock that sets the pace for everything. Think of it like a metronome. The faster the clock, the faster the CPU can complete instructions. Clock speed is measured in gigahertz, or gigahertz, which tells you how many cycles per second the CPU can handle. A higher clock speed usually means a faster computer, though it's not the only factor.